Hello!
The stream is about
Então,
to
como
start. We'll talk about code or whatever we'll talk about
very
today.
good.
It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh,
Very good.
Wait, I don't have any
drunk a little bit
hair.
of alcohol, so
Maybe
We'll-
put some
we'll see how
pants
useful
on
I'm gonna
and
be,
I am
but-
good to go. So get ready whenever you are.
no, but sounds like I'm gonna love
Cause
it.
the stream is about to start. Get ready whenever you
Are we live?
Cause the stream is about to start.
Programming skill. Yeah. Let's hope I'm at that perfect level then. So I'm gonna be like creative enough, but not totally destroyed. Oh. Oh, okay.
Hello everyone and welcome to day 23 of Advent of Code. And David's mic was open the whole time. Go figure, it's one of those things, we are doing it live, so it goes. And now you all know about, and my voice was not being streamed, but now you all know that we were talking about the Balmer Peak, the XKCG. So if you drink just the perfect amount, then you'll be able to solve any Advent of Code. All right, so David, do you have news for us? Did you work on anything at all?
No.
All right, I have news for you about day 21.
Great.
Day 21 is that day in which you have a starting point and you will take a certain amount of steps, and you can take north, east, south, or west. And after this certain amount of steps, in how many spots could you end up? That's the question. So for instance, after one step, you could end up in these 2 positions, or after 2 steps, you could end up in these 4 positions. After 64 steps, how many places can you end up? And we solved this part. Easy enough. Dynamic programming. Then, what happens if not only you can take much more steps, but also the board is now infinite and it spreads in every direction, repeating itself? Well, I was thinking about this and I was talking to Abby about this, and she was very happy that I am doing all these puzzles and bringing them up in conversation all the time.
That's great.
I think I plugged my computer into an outlet that doesn't work. Isn't that great? My battery is going to run out eventually. Let's see if this other outlet works. Nope, it doesn't work either. Excellent. Well, so I was looking into this problem and I was thinking, there is the problem of going infinitely, or as many steps as you can. In this case, it's like 26 million steps in one direction. And of course, you want to avoid the obstacles, but you can try and go as far as you can. But there is also the problem of that fellow who will just hang around in the neighborhood, and they will go to school and come back home every day for the rest of their lives. And I was thinking about this problem. I was thinking, oh, hang on. There is kind of a notion of parity going on here. As in, if you start here and go there and come back infinitely many times, or as many times as you can, arbitrarily many times, what is going to happen is you will always be on this spot in an odd number of steps and an even, in this spot in an even number of steps, right? You will be here in 1 step, here in 2, here in 3, here in 4, and so forth. So there is kind of this notion of parity to the blocks. Is this, I could ask the question, is this then an even block or an odd block? And if that's the case, then it's like a board of chess, There is like black squares and white squares, and the black squares, you can only get there in an odd number of steps, and the white squares, you can only get there in an even number of steps. And given that our number here, the giant number, is an odd number, we could do something based on that. And based on this insight, I was even like tracing routes in my head. Like, suppose I am here in the middle of this space where I can do anything. Even then, this notion holds, because if I start here, I can only come back here after an even number of steps. I may go to the right and back, but I could also go to the right, down, left, and back. That's 4 steps. That's also even. So it seems like this property holds. And then I decided to plot the results of the first part of the puzzle. And
Yeah.
what came out of it was kind of surprising. So this is the input board for the example. And this was the result of running 64 steps. And you can see that indeed there is this notion of parity, right? It's quite a pattern. And what is even more interesting to me is that it doesn't really matter if I can go through the wall. In this case, of course, I cannot. But it doesn't matter, because to go around the wall, it is as if I have gone through it in terms of parity. So the walls don't break the parity, because you have to go around. And by that argument that I was showing before, where you can like do a little loop, the parity still holds. And I was like, ooh, that's interesting. Now I want to see the parity of the 64 steps on the big board. And guess what? Check what I saw. Isn't this interesting?
Yeah. But why isn't it on the outskirts?
Well, because
Why does it stay in the diamond?
Because I start in the middle, and I bet that the S is smack in the middle of this board, and it is.
Yeah.
And then I will, first of all, it's kind of interesting that this whole line is spaces. And I haven't checked, but there is a high chance that the whole column is spaces as well. And to check that it is a tad annoying. Can kind of visually inspect it, but
Yeah, at least going up holds, so
yeah, I have only selected dots. So the way that this works is kind of like I can pretty much find a path to go anywhere in the diamond, and it kind of expands in a nice fashion. Not only that, remember that I showed this on the mini map, and I was like, oh, isn't this interesting? It has a lasagna.
Yeah.
And I thought it was aliasing. I thought that the lines were too long and they were wrapping here, but for whatever reason, the wrapping was doing a diamond. But no, if you really zoom out and you squint, you will kind of see a diamond in the input.
Yep, we can see that.
So yeah, that's another.
That's a lot of insights. A lot of insights.
Yeah, so that's kind of interesting. So my idea then becomes, how about we count how many steps it takes us for us to get to the edge of the board? Well, that's kind of convenient, because that's the answer to part 1. We learned that with 64 steps, I can get to the edge. And then I ran it with 65 steps just to make sure that I wasn't seeing anything crazy. And indeed, with 65 steps, the pattern continues and I get 1 step further on the edge of the board. We have already noticed that there are no walls at the edges, which is also convenient. So my idea really is, how many steps does it take me to get to the edge of the board? 64. So with this amount of steps, how many boards can I go through? And that's probably simple division, right? And then I will have a concept of like a huge losange that covers...
What is that number, sorry? The actual number of steps he needs to get today.
Yeah, this number...
What is that number?
This number is the number of steps that we will have to take. So the question is, how many blocks can I get to in this many steps? So with this step, it becomes kind of a simple division, and I will be able to answer how many boards will I have going up and down and left and right. Then I will know how many boards I have covered completely, because as I expand this, I bet that I will be visiting these places as well, right? So I'll be expanding this and I'll fill in many full boards. And then on the edges, I am pretty sure that they made these inputs in such a way that you will fill in right at the outskirts of a losange like that. So we will be able to just count how many hashes do I have inside. And with that, I will know how many dots I have available. So divide
Yeah.
that number by 2, because as you can see, in an odd number of steps, I get to half of them, and in an even number of steps, I would get to the
Yeah.
other half. So divide by 2, and Bob's your uncle, that's our answer. Now, I haven't really fleshed out this answer, all this counting argument, and how all this extrapolation to go from 64 steps to this. So I haven't really fleshed out the idea, but I found many
Yeah.
holds to continue the climb.
Yeah, 100%. Just one thing I didn't totally understand in your explanation is this diamond shape. Like, yeah, it has this diamond shape when you looked at it without filling in the O's, right? So why does it have that diamond shape after you filled in the O's? Why doesn't the O's... Is that just because of the number of steps you've done, it doesn't fill to the outside of the
Correct.
board? What is that? I don't understand the significance of the shape.
Well,
Is it just because of, like, that's just the shape which forms if you do those numbers of steps? But I don't understand if that's useful for, like, extrapolating the problem out.
well, it is helpful that we will know that we will cover full boards however many times, right? That's as useful information to have. So I can simply look at the number of dots in the graph, or sorry, in the board, and divide by 2, and I will know how many O's I will have for many of the boards, which I will be able to fully visit. And then the only problem now becomes at the edges. So it is a much simpler problem, because I'm not now asking with 26 million steps what are all the places I could go to. I'm just asking, with 26 million steps, how far can I go? Which makes the computation much simpler, because I can prune the paths that would take turns, or that would take cycles, that would visit the same place again and again. Because I'm now asking, how far can I go? And then at the very edges of how far I can go, I suppose that we will have this kind of shape. I suppose that we'll be here on this outskirts that will make things easier.
Yeah. Okay. But we still have to... Is the, like, outside of that border, is that a duplicate of what's inside? Can that be used?
I thought about that, and I tried to see patterns, and then I started to look like one of those people with, like, strings on the walls and stuff. So I stopped. I don't see any patterns beyond what I mentioned.
Okay. Cool. All right. Well, it sounds like we have, as you said, a lot of footholds.
Yeah, and I will want to play around with these ideas at some point, but I don't think that we need to do that right now. I think that we can either talk more about day 22 if you have some... I just submitted the wrong answer again by mistake. If you have some more insights into this, or we can look at day 23. Perhaps it is an easy one, and we could do part 1 of that.
Yeah, I don't have any more insight for day 22. I can't even remember. So this is the one where we're placing the blocks on the matrices, on the matrix. Nah, I feel like doing day 23. What about you?
Yeah, let's dive into day 23.
All right, let's do it. You're driving.
I'm driving.
Perfect.
A long walk. The elves resume water filtering operations. Hooray! We are helping a lot, David. We are helping a lot.
That's good.
Clean water starts flowing over the edge of Island. They offer to help you go over the edge of Island 2. Just hold on tight. Oh, I already see dots and hashes. I'm like, just hold on tight
Oh yeah.
to one end of this impossibly long rope, and they will lower you down a safe distance from the massive waterfall you just created. As if I don't even remember the waterfall from day 22. What was that about?
No.
I forget.
Uh,
Wasn't it
yeah.
like blocks falling? I thought we were playing Jenga.
Mm.
As you finally reach Snow Island, you see that the water isn't really reaching the ground. It's being absorbed by the air itself. It looks like you finally have a little downtime while the moisture builds up to snow producing levels. Snow Island is pretty scenic, even without any snow. Why not take a walk? There is a map of nearby hiking trails, your puzzle input, that indicates paths, forest, and steep slopes. You're currently, let's see if there is any pattern here. We can see that there is only one entrance and one exit. And I suppose that there is only one path that will get you from the entrance to the exit. So it's like a maze.
That's cool.
Your current,
And we've got a different character, which is nice.
yeah, we were not used to these things. You're currently on the single path tile in the top row. And I bet that your goal is to reach the single path tile in the bottom row. Because of all the mist from the waterfall, the slopes are probably quite icy. If you step onto a slope tile, your next step must be downhill, in the direction the arrow is pointing. To make sure you have the most scenic hike possible, never step on the same tile twice. What is the longest hike you can take? Okay, I think I understand it. In the example above, the longest hike you can take is marked with O, and your starting position is marked with S. So this is kind of like Dijkstra, but upside down, right? We want to take the longest path. And actually, it's not even Dijkstra, it's A star reverse. But anyway, because you're not interested in all the paths, just the longest. This hike contains 94 steps, and the other possible hikes you could have taken were 90 and blah blah blah. Find the longest hike you can take through the hiking trails listed on your map. How many steps long is the longest hike? And now let's see the input. It is kind of big, but I can see that there are usually just like one path that you can go through, and there aren't that many bifurcations. And of course, the bifurcations are what makes this problem interesting, because if it's a single path that you can go through, it can do all twists and turns and it doesn't matter, right? There is no choice to be made. And I don't really get the point of the arrows. It's a one-way street, right? It's all there is to them, right? Yeah.
Wait, sorry, did you couldn't hear me then, could you? I was just saying those characters, there's nothing, they don't describe anything about them in the description. For now, we ignore them and they'll be included in part 2.
No, they are being described. There are icy and steep slopes, which means that you cannot climb up on them. You can only go down on them. So if I am here, I am able to go down, but I'm not able to take the other way.
Is there ever a scenario where you'd want to go back on yourself?
No, but there could be a scenario in which I am arriving here and then bam, no, I cannot continue. But if I came it from the other side, then I could go this way. So it's like a gate that only opens on one side.
Right. Yeah, makes sense.
Okay, so I am driving, which means that we will be using some JavaScript for day 23.
I'm excited. I'm going to time you. I think you could do this in 30 seconds. No, I'm only joking. No, but I'm looking forward to you coding this. It's going to be cool.
I am glad to hear that.
Don't forget to share it with me.
Oh yeah, right.
Brilliant. Thanks.
So as usual, let's do the parsing, and this is going to be the map of the hiking trail, which is our input, trim, and say with me, split on the new line, and map the
Map.
line dot split on any character. Then our initial position is going to be put on our, oh, look at the mini map.
Oh,
Cute. So,
what is going on there?
well, it's just the maze, right?
Oh yeah.
So you're going to have a work list, which is
But I
going,
was just thinking whether there was a pattern you could see. Not quite, but it looks cool.
it looks cool. And our initial position is going to be X, I want to say 0, 1,
Sure.
and Y 0. And we will have a set of visited, what do they call these blocks?
Scene.
Tile, they call it tile. Visited tiles, and it's going to be a set. And I think that that's all we need.
Yep.
So, oh, no, I also want to know... no,
the
that's
distance,
it,
okay.
that's it, actually. So,
I think you need to know the. Oh, you can infer that from visited tiles.
yeah. So, yeah, I can. That's what I was thinking, that I need to count, but I don't, because I can just look at the size of the set. Oh, but if I am doing that, then I should put this tile in there, right?
Yeah.
Or maybe no, I could not do that. I could do that in the
Plus
while.
one.
So while the work list, it still has work to do, I will do a bunch of things later to check if this work list item is sensible. But what I'm going to do in the end is take my work list and push.
Right in Python.
Yeah, I was going to say append. I'm going to push 4 items. The first of which is...
It's funny, it's getting to the stage where you don't complete your thoughts, and I know what you were about to say.
Yeah, we are really developing a great companionship through this advent of code situation. I'm loving it. So the set of visited tiles will be updated here. We will do something like... And I'm gonna call this like a state.
Okay.
Oh, that's not even it. And I will have visited my position. I don't like how this is tiles and this is position.
Yeah, but tile, no, I think it does make sense because tile is different to...
So in that case, I'm renaming this.
Yeah.
Which means that at some point I will be able to do that. And what I'm more interested in
tile
doing...
is actually the like the value, right? Like the character at that position.
You are correct. And at this point, we all know how this goes. This is the top. This is the right. this is the bottom, and this is the left.
Nice.
And with that, we are able to do the bulk of the work. So if my state X is off of the board, so it is less than 0, or if my state X is greater than map at 0 length, greater than or equal, really, or the same for Y, or if my visited positions includes, no, has, it's a set,
Yes.
the, as it turns out, this, right? So we might as well have it above, which is position, something like that.
Key?
Yeah, I can rename that to key.
Or position key, but yeah.
Position key. There.
Mm-hmm.
And also, I will want to check that the map at y, x is equal to a hash if any of those continue. If the map, or not even that, if, yeah, I'm gonna do it this way. If the y is equal to the map length, it means that we have reached the last line. In other words, we are in the success condition. Just console log the visited positions, which I should compute up here.
Nice.
Size and break. And now let's deal with the slopes. So we need to not only take care of positions, but also directions. So the work list now becomes this. And to begin with, I will be going... to begin with, it doesn't really matter. But later, when I am going, I will be going in a certain direction. So on this one, I am going up. On this one, or actually, I'm going to use the symbols that they represented. So this is going up. This is going to the right. This is going down. And this is going to the left. Let's see if they did any funny business with the arrows. Are they simply like the letter V and a caret? They are not a caret. Are there any arrows going up? I don't see any. Oh well. I'll include them for completeness.
Okay.
And then I will check if my map is not a dot and my map is different from my direction.
Oh, very nice.
Then skip. And
That's so nice.
thank you. And yeah, it's
Did you do
state.
structure direction?
No, it's state.direction.
Yeah.
And What else may I be missing?
You need to like get the longest path, not just
Oh yeah.
break on the first one.
So in the end, I want to get my work list and sort by, I will have a stage A and a stage B, and I want to make sure that my stage B dot visited positions dot length is,
Isn't it size?
yes, it is size. And does that do it?
Yep, first time.
And I want to push and shift. No, I want to push and pop. Yeah, pushing and popping is the fastest that we can do. So let's make sure that we have the largest in the end, which means that I want to have A and B here.
Oh yeah.
Well, I'm doing the naive thing, so clearly performance is not going to be a big deal because for part 2 we're going to turn this on its head,
Yeah.
but whatever. So let's see. We start here.
I always feel so optimistic after part 1, and then find out.
Not on day 23, David. Okay.
I think that's good though.
I feel like I am missing something like
This is Did you see that?
I see that. Yes, you are right.
Cool.
And let's see what else. I feel like I'm missing something to avoid repeating stuff on the work list. I guess that's the visited positions, right? Yes, it is. And I will just quickly skim over to see if I am not making any other silly mistakes.
And should this be... I don't know, I was going to say it needs to be +1, but actually, because you add it here, it's great.
Yeah, that's why I moved the line up.
Mm-hmm.
Okay.
It's looking good.
Yeah, it's looking good. I want to run this. It's stage, direction, and all of that, right?
Yeah, you need to destructure Ys, I guess. What?
Oh.
That doesn't make sense.
It does.
That's annoying. Should we just have it flat? No, I guess not. It would make it annoying. Y is not defined.
$91. And this high contain 94 steps. It's close enough.
Yeah, that's fine. Yeah, let's do the real one. Close enough.
I bet at day 23 they are giving us like some margin for error. Well.
Yeah. Oh, that would be nice.
Let's print this set and see what comes out of it.
Yeah, good idea. Or draw it. I would draw it on the maze.
That would be ideal, but let's see if just by looking at the coordinates we can make sense of something. So let's see.
Mhm.
We are here, then we go down, then we
Yeah.
go to the right, then we go down, then we go to the left, and we are here,
So that's
and then
y3,
we go down,
x4. Yeah.
then we go to the
Y3, x3, sorry.
yeah, and then here we have a bifurcation. We could go right, we could go down. What did we do? We were in x equals 4, y equals 3. Yes, and then we go down, and then we go down. We decided to go down here. Was that the right thing to do? Nope.
I guess, like, is the sorting not sufficient to guarantee it? If, like, we didn't break and we found all the paths, do we find the longer path?
We must, right? We will find a path with 91. Not even that is right. 75.
Looks like there's an off by 1.
83. 87.
Mm-hmm.
There is an off by 1.
Wait.
95,
Yeah.
which would have been the right answer. So yes, there is an off by 1. And 83.
But there's also, they're not in order here. What's the order that we, if we don't print out all the visited positions just so we can see what order they come out? Yeah, why are they not coming out ordered?
Maybe I messed something up here. I don't know. But first I'm interested in squashing this off by 1 problem. What could it be?
I mean, it might just be they're counting in a different way. Like that we're counting the first. Yes, we're just counting the first cell when they don't count it. They're counting the steps, whereas we're counting visited positions. So it's just -1 from all of our visited positions.
It's just because they didn't count this starting step, right? So we could just say size -1 maybe.
Yeah.
Or maybe we could do it the other way around. How about that?
That's nice. Yeah.
There. Off by 1,
Okay.
eliminated. But, well, I'll say one thing. We did not get the longest route, but we could get all of them and sort.
Yeah. I mean, that definitely could be doable for this size of graph.
And they call it a path, a route, steps, hike. They call it a hike. And can even be a set. No, I want to sort it. So
Yeah, nice. Does that complete quickly enough for the big input?
okay, I have the right answer. Does it complete quickly enough for the big input?
Probably.
So, How are things, David?
I'm curious why the sorting didn't work.
I am curious about that as well. So let's speculate. Oh, no, let's not speculate. Why speculate about that, David?
Why speculate
I
when you
don't
can
care. We
get
have a
your
star,
stars?
David. Good job.
Brilliant. Fantastic. That was very good.
Okay.
All right. I'm curious. I'm not guaranteeing that I'm going to be able to contribute that much, seeing as it's day 23, but I'm very curious. What's part 2 about?
As you reach the trailhead, you realize that the ground isn't as slippery as you expected. You have no problem climbing up the steep slopes. Now, treat all slopes as if they were normal paths. You still want to make sure you have the most scenic hike possible, so continue to ensure that you never step onto the same tile twice. What is the longest hike you can take? In the above example, this increases the longest hike to 154 steps. Find the longest hike you can take through the surprisingly dry hiking trails listed on your map. How many steps is the longest hike?
Are you joking?
This is gonna make the state space larger, you see.
Yeah, but it's going to be fine. So you just get rid of that clause and we get the answer?
Yeah, as long as I have the syntax right. Oh, I get rid of all of that, actually.
Yeah. Let's see.
But I still get 94. No, I'm running the new one.
But that might... Oh, yeah, that's wrong.
Wait, what?
That doesn't make
That
sense.
doesn't make sense.
Because we're not checking the direction anymore at all. We could even delete direction from the nodes.
Yeah, let's do that.
That doesn't make sense. Yeah, let's list all of those out. Yeah, definitely.
Ah, our answer is in there.
What? The sorting doesn't work?
No, we don't even have... Oh, we have 94 and it's in the middle of there somewhere. The sorting doesn't work?
It doesn't sort in place? Maybe it doesn't sort in place. And maybe that's why it didn't output the longest one.
Oh.
Yeah, you need to... It doesn't sort in place. You need to assign it. How hilarious.
No way.
Yeah, must be. Hover over it. Hover over it.
Wait a second, and we have two ways of getting to 118. That's interesting. No. Wait a second, is this doing some wacky thing like lexicographical sorting on the digits? Is sort by default not doing it with the integers but transforming them into strings?
That could be true, actually. It is in place. It is in place. Okay. Yeah, you're right. You're right. You're 100% right. That's exactly what it does. It does do the lexicographical sorting. There we go. So now I'll just run it for the real deal.
And then you were telling me that you went to a party tonight.
Not quite. Just went for dinner.
Okay.
Let's have a look. Did we find any paths?
Oh, well, I can answer that.
I'm surprised. I feel like it should.
You find some
Okay.
paths.
But maybe the longest path. Are there any loops?
Oh, wait, that is what was messing up the sorting when we started? No, it was not.
No, it was messing up the. That is the answer to why. Oh no, we were doing it
We
properly.
were doing it properly because we had to look into the object to get the size of the sets.
Yeah, yeah,
It doesn't hurt to try.
yeah.
Cycles,
I
you
think there
ask?
could be cycles, but if there were cycles, then we would just like
We
not
would
pursue
eliminate
the cycles.
cycles.
Yeah.
You know what's funny? This puzzle is exactly right to fit on my screen.
Mm.
We are starting to see signs
That-
everywhere, right?
Yeah, it does look really cool actually. In the mini map. This would be a nice one to visualize.
Yes. We could also memorize.
Um,
No, not quite, because we want the maximum. So you may want to redo the work to find a bigger path. Longer path.
well, we could do the sorting or a Dijkstra type heap thing, whatever. But it should complete. Let's see the console. We'll keep it open. I'm surprised. I'm really surprised.
Yeah, it's funny that it found one and then it didn't find more.
Can we, whilst we wait for it to complete, can we write a debug function to print it out?
You want to see the map with the...
Yeah, I
O's.
want to see it filled in. Well, I would maybe not choose O's, but yeah.
Okay. And where do you want to print it? Do you know already?
I think just like after a certain number of cycles, like see where if it's progressing.
I kind of
Like,
want to
is it
see
stuck
this one. I kind of want to see this one. So I'm going to write it here and then we can extract it and stuff. So... Or maybe, I know that you like functions. I'm going to create a function.
All right.
And I want to have a notion of visited states, visited positions. You said you didn't want the capital O character. Can you choose a character that you would like?
Yeah. Let me find it. How about that one?
Sounds good to me. Well, actually, I'm going to write it slightly different. Not your character, though. That's staying. I'm going to write the whole line slightly differently. It's pretty much what I want. So now... And we haven't had a single other answer. That's fantastic. Let's print this answer that we get immediately. Let's print it.
Oh, this so this new line should be here, like that.
Where was it before?
It was line below.
Oh. Yeah. Okay. Thanks. Yeah, it is a path. Likely. Not sure. Looks like a path.
Okay. Because, like, my thinking is that... Wait, do we need to check that it's not going on a path already, like, visited? If you see what I mean? So, like, if two paths are, like, diverging, if they come back to an already visited node, like, we should memorize that, if you see what I mean. Like, it's just joining onto... We've just found a longer route to the same node.
Isn't that what the sorting of the work list was supposed to do for us? Why is that not working?
I mean, we deleted it, but...
Oh. But why didn't it work to begin with?
Would it have done that for us? It would have always chose the longest route, but it wouldn't have... It wouldn't have necessarily killed... I mean, no, it would have worked for us, because we would have just added stuff to the stack, which we would never explore, because we would have exited early. Like, we would exit when we find the first longest path. So that would have worked. Yeah, should we try making that work? But I guess the other thing is we could just like deduplicate if we've found a longer route to a particular node. We could store the distances for every single node. And if we have found a longer path to that node, then discard this. Like, discard this node.
Yeah, I see what you mean.
That would be one way.
I'm still trying to puzzle through the following. We split and as we are going through the maze, we split, but we will keep trying to advance on both fronts because no, we are not. Think about it this way. In the way that we implemented the original idea, we find a bifurcation here. And then the code is going to do whatever it does. It will just use one of these two paths arbitrarily, because so far there is no notion of order yet. And then it goes to the right. Now, going to the right has a longer path because it has explored more nodes. So it gets chosen again and again and again. And we ended up just visiting that. And if it can reach the end, it will reach the end. And then we'll say that that's our answer. But that's a silly thing to do. The trick of using the sorting to find the shortest path works because we explore the right. And then what is the shortest path? It's to explore down. And now what is the shortest path? It's to explore the right. And what is the shortest path? It's to explore down. And then we keep advancing both fronts. And if both fronts eventually converge, then we will have found the shortest path to that convergence point. But it doesn't work to find the longest path because we get into this vicious cycle of only exploring one of the paths.
That's true. That makes a lot of sense. That makes a lot of sense. Yeah.
So
Yeah, that's really good. Really good insight.
flipping Dijkstra on
So
its head, it's not as simple as
yeah.
getting a person,
Yep.
I guess a Dutch person, and turning them upside down. I guess there is more to it. Dijkstra is Dutch, right?
I don't know.
Now we need to find out. Yeah.
Nice. Um, so what about my suggestion? Or do you have a nicer suggestion?
I have a good feeling about it, but I'm trying to think of like what is it that makes the great that makes Dijkstra work for the longest path? Because you can't just be greedy and try to keep exploring the longest path. You need to make something that forces you to go back and forth. You kind of want to get the least number of steps when sorting the work list.
Wait, hold on. We don't even need Dijkstra for the shortest path. We can just use BFS. Dijkstra is only necessary when you have a weighted graph. BFS is guaranteed to find the shortest path regardless.
What about the longest path?
Uh, well, I think with the longest path, don't you always have to explore all the nodes? Like, there's something particular about the minimum path, or like all the paths. Like, the minimum path, you don't have to explore all the nodes because you're advancing all the paths at the same time. And so, therefore, the first one which reaches the end is the shortest. But for the longest, you don't know if there's a longer path until you've explored all of them. So there's no like trick without exploring all the paths. The only thing is you don't want to like maybe re-explore a path you've already explored.
If that is the case, which it may very well be, then the trick to solve this puzzle is more like, let's say, an implementation detail like memoization was in another puzzle.
So like, yeah, or
Are we
like,
getting more boards?
yeah.
Just one.
I was just gonna say like just to think about it. Like if you think you've got track A, track B, and track C. And the way that BFS works is you've got like you're advancing this one, then you're advancing that one, then you're advancing that one, and then you find out that like B reaches the end. And so you know that like that's the shortest one. But you don't know which one is the longest one yet. And you need to keep advancing these until this one finishes, and then you know that this one will be the longest.
Mm-hmm. Does it help at all to go from right to left? Does it help at all to start at the end of the puzzle and try to get to the start? No, not really, because the problem is kind of symmetric then.
I guess you could theoretically know, like if you theoretically know what the somehow like some constraints about the board, like the dimensions of the board and how many walls there are, theoretically you could know what the longest potential path is, and then like I don't know. Like I'm thinking maybe if you know some constraints about the path, that could help, but I can't think of some how you could use it right now.
One thing that I'm thinking about is that maybe we could abstract this maze, because we are doing a lot of work to traverse the steps. We are putting things on the work list and taking them off and all of that. We could, instead of just parsing the puzzle, the maze, we could also abstract it into a graph where one node of the graph would be this whole trace, because so far we haven't had a bifurcation. So all of
Yeah.
this becomes a single node in the graph, and this is a kind of a parsing problem, I'm gonna say. Not really, because you have to traverse the graph to figure this out, but it's more like a pre-step. And then when you get here, this becomes two arrows, and this whole trace becomes a node in the graph, and this whole other trace becomes another node in the graph. And if we do this, then we would be saving a lot of like churn in terms of computation.
We kind of are doing that in a way. Like that is what our state is. We're like reducing an entire path into one object, which is the state. It's not a million miles away.
Yes.
I guess it's like if you come back to a node which is visited by something else, and you got there and and you found a longer path there, then you can stop the other path, I guess, somehow. How would you stop the other path from iterating? Because like the optimization here is like the memoization thing, right? Because even if you like abstract these things into like segments or like disjoint like sections, the wasted computation which is making this slow is only when we're like re-exploring a whole thing. We're like redoing work. What's an example of where that happens? So like when you bifurcate, but then you end up exploring something which has already been explored. Like you go up somewhere and then, like if you do a small loop, when you could have just gone down, then that's like that whole loop. Like whatever you've explored down in that direction is like you can just leverage that somehow. What are you thinking?
What I'm thinking. What I'm thinking is when we had the arrows, we got a longest path that was shorter. So it must be the case that we must go against the arrows. So one thing that we could do to try and make our search get to the right place faster is to try and go against the arrow. So invert the meaning of the arrow. We would still have to explore everything, but at least it's a heuristic that points in the right direction of making things longer than before.
Yeah, that's true. That's true. It's guaranteed that we're going to go up some arrows that we didn't before. That's 100% true.
And it does make the state space smaller as well, right?
One second.
Let's see if we have another answer here. Not yet. Wow. It's very surprising to me that it takes this long. Is this input architected in such a way that this exact implementation is super, super, super slow?
That's why I'm curious to see, like, where is it stuck? Like, when the visited node gets over, like, 1,000, like, where are we iterating around? Because, like, it doesn't seem like such a big graph.
Does not seem like such a big graph.
Like, how could it do a loop?
Well, every bifurcation is multiplying by 2, so if we have 64 bifurcations, that's already a lot. And you can easily fit 64 of them here.
Well, I guess that's the memoization thing, isn't it? If we can just memorize this somehow, then, like, we're laughing. I have a really ugly way of memorizing it, but I'm sure you can think of a better way.
I'm also noticing that every arrow seems to appear in in this kind of every bifurcation is there are arrows around it. It seems like there are no bifurcations without arrows around them. At least that would help us find the bifurcations if we decide to turn this into a graph. That's kind of a quick and dirty heuristic to do that easily.
Hmm.
Every time you see an arrow, you know, okay, I'm about to get into a bifurcation.
Yeah. And that's maybe why it was so quick for part 1.
Because on part 1, it
There
was
were no
pruning. Like,
bifurcations.
for instance, when you get here, you will not be able to follow one of these paths.
Mm-hmm.
So maybe that's a good heuristic. We know that for part 1, we did not explore this. So we know that the answer could very well be here. So I can see that every bifurcation has kind of a gate going in and then gates going
Well,
out.
I don't know that it's guaranteed that you have to follow it.
No, it's not guaranteed,
Like,
but it's a good heuristic.
that's true. So you would maybe sort it by that.
Yeah, I was thinking of doing something like this. Every time that you see an arrow or that you go over an arrow, you are about to step into a bifurcation, because if my inspection here, my visual inspection holds, every bifurcation is delimited by an arrow. So what we can do is, if you see an arrow, you are about to get into a bifurcation. So now you want to not follow arrows. You want to go against the arrow, because that is probably the longest path, because that's a path that we have not seen in part 1.
Mm-hmm. I don't. Yeah, I see how the heuristic is better, but I don't see how it's going to be like it's going to change the complexity necessarily, because we still haven't found a single.
Well, if they made it particularly easy for us, such that you always have to take the wrong way on bifurcations, then we could just try and see how many steps it takes for that one and put it in the puzzle answer and see if we get the right answer. Do you want to try that?
Yeah, sure. Let's try that.
Meanwhile, let's keep the thing running and let's see. Nodwas1 is here. Hello. I was recommended the parsing the map as a directed graph. Yeah, we are thinking of doing that, but we'll see if we can get by with this silly idea. So we have to revisit this direction thing. We have to put it back, because I would refer to part 1 and copy stuff from there. My computer is starting to throttle the performance because the battery is running out and the outlet in which I'm connected is not functioning.
So, now the pressure is on.
Yeah, we have like about 10 minutes to continue here. So I restored the notion of directions. And I will also have a notion of like go against the flow, which to begin with is false. Or I guess against the slope. And
I guess you need a let.
Actually, I need it to be in this stage.
I see.
Against the slope. And then, well, not quite, because I will need to compute it. So if I'm on a dot, I will get it from the stage. Otherwise, I will flip it. And here, if that condition from part 1 if I am going against the slope, I guess it goes like this, but let's read this carefully. So if this is a slope, and I want to go against this slope, but I am going the right direction, then I'm not going against this slope, so continue. And if I'm not going against this slope, it means that I'm going with this slope, so they need to be the same, and they're not, so don't continue. Okay. I think that this does it.
Mm-hmm. Could we, out of curiosity, have a global scene and log every time that we visit the same node to get an idea of how much duplicate path traversal there is? Let's just run this, see whether we get our answer quicker.
Now that's our answer.
Well, undefined.
Yeah. Doesn't really matter what we do. Okay, it does have to do with our condition.
Mm. So yeah, read this through. So if it's a thingy character and we go against the slope, then go against the slope. Wait, hold on. You're just saying isn't this always going to be true? Can you explain this logic?
Which logic?
Why don't you sort it by whether...
Oh, I'm actually trying to prune the path completely. And I guess that's the problem, right? If I prune the path completely, then I cannot just take the wrong turn on every bifurcation. I have to take the wrong turn sometimes, so I would have to sort.
Wait, but I don't actually totally understand this.
The idea is, and I may have implemented this wrong, that I want to do this flip-flop situation, so going against this slope every other time.
Yeah.
And if I am doing the normal slope thing, which we did in part 1, then do the normal thing. if I am in this go against the slope stage, which is a special stage, then do the same logic but in reverse.
Yeah.
But here is the truth, people. Here is the truth. Low battery. My outlet isn't working. So it's time to say goodbye. And also my brain is fried. So it's a perfect time to say goodbye. So
Yeah.
go ahead.
No, I guess like you said, so you're alternating whether you take it or you don't, and basically there is no path where if you alternate it perfectly, you end up in the right place.
So we will have to do something else, and I would argue that it doesn't hurt to do the parsing into a graph in which the bifurcations become arrows into different nodes. I think it could be handy. It may reveal something, especially if we plot the graph using GraphViz. So, and I am interested in doing that. What is the library that you used in JavaScript?
For what?
GraphViz.
Viz.js or something like that. If you say like graph viz TypeScript or what, might be that one. I'm not sure. Does it mention GraphViz in the GitHub?
Is it this?
No. It's not. Try GitHub. GraphViz TypeScript GitHub.
Is it this?
No. I think it was Viz.js. I'll just send you the right one. I think you had it right the first time.
Was it this?
Yeah, it's this. It's this one.
It's this one. Okay. And then there is a GitHub here.
Yeah, and then does it mention GraphViz there? Yeah, GraphViz in your browser.
Okay. So yeah, I think it could be nice to visualize this graph. It may give us an insight. It gave us insight into the problem of the computer that has flip-flops and conjunctions and all of that. So I think that for today, we should count our blessings. We got 1 star.
Yep. Just to say, do you not think it will work to do the like the pruning by like storing the distance to each node and then like pruning all the paths which are not the longest path? Do you think that strategy?
Yeah, and your idea is to do a BFS, right? When we reach a node, we want to saturate all the possible ways to get to that node.
No, it would be to do exactly as we've done, but just keep a map of the distance to every node in the graph. And if we ever encounter, and we assign an ID to every state object that you have, and then we keep track of which state object has the longest path to that node. And then we prune the states which are like considered now obsolete. We keep a map of those ones which are actually maybe that doesn't work. I had an idea. Yeah, maybe there are some legs there, but actually it's not a fully formed idea, so never mind. We can discuss that next time.
Okay, but we got a star. It was not nothing.
We got a star. 100%. Yeah, that was great.
Yeah. It's not a big graph. Brute force works. Huh. Well, another thing I will do is I will make the code. I will leave the code in the shape that does the right thing, because right now I think it's blowing up. And I will leave it running. Never hurt anybody.
Yeah.
I don't think it will finish because it didn't work on other days, but you can try. So with that, I'll see you maybe tomorrow, maybe, I don't know. We'll keep in touch.
And for sure.
And we'll do a surprise stream like today.
Sounds great.
Okay, so thank you, Ivasler and Nodwas1 for joining us here on the chat. Thank you to everyone else who is watching. Thank you very much, David. You are the best.
No, you.
And I'm looking forward to seeing you again, probably tomorrow, but soon.
I'll see you soon, Leandro. Have a great rest of your day. Enjoy your dinner. Bye
Bye.
bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.